Hello friends, today we will discuss about the dry jet weight spinning systems. So in last lecture we have discussed about the weight spinning systems and dry spinning system. So how it is different from your dry and weight spinning system. So as we earlier we know that the solution spinning systems has the two basic types. One is your wet spinning system and dry spinning systems. These are basic two types of your solution spinning systems. But how it is different, that is your dry jet wet spinning. So initially we will discuss that is dry spinning systems. So in dry spinning systems, the polymer is dissolved into certain suitable solvent and is extruded into the coagulation bath containing the non-solvent, or it could be your with the help of hot air in case of your dry spinning systems. So in both these systems the solvent has been removed, whether it is could be your chemical bath systems, or chemical means whether it is could be solvent has been evaporated by means of hot air. But in case of dry jet weight spinning systems, how it is different? So in this case, when polymer is extruded into the air but eventually taken into the coagulation bath, that system we call as the dry jet weight spinning systems. As the name suggests that the spinning jet is in the dry state, unlike in the wet spinning systems, because in wet spinning systems that spin rate has been kept into the coagulation bath, so that we called as the wet spinning systems. So in this case the spin rate has been kept in the state. So first we'll see the wet spinning systems. Here we can see that I will get to know that the same systems like dose, we need to prepare this dope solution by dissolving the polymers with the help of suitable solvent. Then metering pump has been there. They will force your polymeric fluid or polymer solution to the metering pump and to the filter unit, and then the filter unit to the spin rate. And in this coagulation bath, your chemical bath, or other terms we called as chemical bath, the polymers which has been extruded, and during this process whatever the solvent which has been used for dissolution of your polymer, that has been removed, and then it is taken for the further operation. In dry spinning systems, what is the dry spin, like filament has been taken from your spin rate, and in this case hot air or hot gas has been transferred for the solidification of your filament. At the same time, this hot air has been used for the evaporation of your solvent. The solvent has been evaporated by hot means. So we have seen two systems, that is your wet spinning system and dry spinning system. In wet spinning, the spin rate has been kept into the coagulation bath, and in coagulation bath whatever the solvent has been used, that has been dissolved or that has been removed by means of chemical, and in dry spinning systems that has been evaporated by means of hot air. So you can see here in dry jet weight spinning systems, the spin rate is just kept into the dry state or dry, and below that there is a coagulation path is there. So this air gap which has been maintained between the spin rate and the coagulation bath, so that air gap also depend upon the which type of fiber we are producing, whether it is lyocell fiber, whether it could be it is acrylic one. There are different types of fibers which can be produced by the dry jet weight spinning systems. So what is the basic fundamental difference between this dry jet weight spinning systems or the weight spinning system is that this air gap has been maintained, and that will ultimately depend upon the which type of fiber we are producing. So this air gap, how it is advantage, how it will change the morphology of your structure of your. So this is the just modification of your wet spinning systems, where the spin rate is just kept outside the surface of your coagulation bath. So in this case, the fiber is extruded into the air or gaseous environment, and then it is pulled inside the coagulation bath. So mostly these baths are deep to allow the vertical movement and coagulation of your extruded fibers before it touching to the guide rod. And this gap between the spin rate and the coagulation bath surface, that we called as the air gap, that will vary with the type of polymer and the technology being used. So in case of acrylic spinning, this gap may be in the few millimeter size. The air gap should maybe few millimeter. In case of lyocell spinning, it may be several centimeters. That will ultimately depend upon your polymer and the technology which we are being used. So this small difference in the arrangement of your spin rate, that will bring the significant change in the spinning performance and the ultimate structure of your fiber. So see, this ultimately embraces both the benefits of your dry spinning system and the wet spinning systems. Unlike dry spinning systems, this air gap in the dry jet wet spinning is very too small to allow any appreciable removal of your solvent before it is prototype fiber has been entered into the coagulation path. So the air gap is very small in case of dry jet wet spinning systems, that will allow any appreciable amount of solvent should be removed before that prototype fiber has been enter into the coagulation path. However, it is much more sufficient to bring these changes on the surface of your extruded filament. That small air gap, that will ultimately brings the change in the surface of your extruded filament. So it has been hypothesized that in case of pan spinning, the kind of dense cuticles is formed on the extruded fibers as they pass through this air gap. So this in turn changes the diffusion dynamics of the solvent and non-solvent during the coagulation of your fiber. So what are the basic benefits of your dry jet wet spinning systems? First is your high speed spinning can be possible, high concentration of your dough, high degree of jet stretch ratio. So these three components, that is high speed, high concentration of your dough, high degree of jet stretch, that all these benefits has been derived because of the use of dry jet and the air gap. While the last benefit, that is controlling of your coagulation kinematics by monitoring the coagulation bath parameter, that has been derived from the use of wet coagulation systems. So the first initial three benefits has been derived from use of dry jet and the air gap systems, and the last one has been derived from the use of wet coagulation. So before that, how the polymer dough preparation has been taken place, that is basically for all this spinning system, whether it is dry spinning system or wet spinning systems, or that could be a dry jet wet spinning systems. This is because the dough preparation is one of the most important process in the preparation of your filament. So in dough preparation, initially we know that the dough has been prepared by dissolving your polymer with the solvent. So the main condition during the dissolution of your polymer with the help of solvent is that the polymer particle should not swell, and it will not be agglomerate to form the lumps. Lump formations should not be there during the dissolution of your polymer with the solvent. That should need to be taken care while the preparation of your dough. So this ultimately, because the agglomeration or the lump formation will create the difficulty in your processing. Therefore, the different strategies are employed. We'll see what are the different strategies has been used to enable this dissolution of your proper dissolution of your high molecular weight polymers. Different strategies has been used for the dissolution of polymers. The first one is your that dissolving that polymer at the low temperature, or in other terms we can say that the dispersing your polymer particles in solvent at low temperature, because at low temperature the solventing power of your solvent is very low, so that will ultimately allow the dispersion of your particle without sticking to each other, because if their particles are sticking to each other they will form the agglomeration and that will form the lumps formations. So then that will not, you will get the processing will difficulty. And after that proper like if you are doing this dispersion at low temperature, there could be proper dispersion of your particles, and the temperature, like after that we have received that proper distribution of your polymer particles, then we need to increase that temperature slowly to increase the dissolution of your polymer particles. So these are the first conditions or approach we need to taken care for the different types of polymers we need to process. Second approach, it is the dispersing your polymer particles in solvent non-solvent mixtures, such as cellulose can be mixed into NMMO and water mixture, that is solvent and non-solvent mixture. So in these conditions the solventing power of the solvent is again very low, and the particles can be easily dispersed in the solvent medium without undergoing the swelling or agglomeration. So therefore the dissolution is initiated under high agitations by the increasing the your solventing power of your solvent. So the next strategy is your the polymer, if you are modifying with the certain different systems, like initially we need to modify that polymer in order to make it into soluble into certain other common solvent. For example, if you want to make this cellulosic fiber, the alkaline cellulose is xanthated. That could, like in viscose we have seen that the xanthation process we need to be carried out with the CS2 to form the sodium cellulose xanthate, which could be soluble, easily soluble in dilute NaOH solutions and can be easily spun by the weight spinning. So thank you so much. So in this lecture we have discussed different strategies for the dissolution of your polymer, dope solutions, and the dry jet weight spinning systems. What are their benefits of your dry jet weight spinning systems, and how it is different from the dry spinning and weight spinning, and how it is benefited for the certain different structural changes in your material. So thank you so much for your kind attention, and we will stay tuned for the next video. Till that, thank you so much. Okay, goodbye.